So day 3, the calculator day for motion stuff. The good news is every concept thing is exactly the same. So velocity 0 means a particle's at rest. Moving to the right, v is positive. Moving to the left, v is negative. Speeding up, slowing down, distance, it's all exactly the same, except that today we're going to get very weird looking formulas because we have the calculator to do all of the hard work for us. So v equals this awful thing, but who cares, we've got a calculator. So example 3, the velocity of a particle is given by that terrible thing, where v is measured in feet per minute. Find the acceleration of the particle at time equals 2. Okay, well, ignore the fact that this velocity looks awful. Just in general, how do we find the acceleration if we know a velocity? Take the derivative. So I want dv dt, and I would like it at t equals 2. Okay, so now this becomes a calculator thing. Like, well, how do I get my calculator to do that? Probably the best thing to do is to put this thing in for y1. So that's ugly, but we can handle this. Sine of, I'm going to be fancy and use the fraction bar thing. X cubed over 1 minus x times cosine of the natural log of x squared. Close the natural log, close the cosine, and I think I've got my equation in there correctly. You guys know this, but anytime you're using the calculator, take that extra 3 seconds to verify that you typed it in there the right way, because your calculator is not going to mess anything up. It's only going to be if you type something in there wrong. Overheard in pre-cal, because they're doing a lot of heavy calculator stuff, one girl said to the other, the calculator's not wrong, you are. It was a little aggressive, but it was accurate. Like, she'd done everything right button-wise, but the formula was wrong, and so of course the calculator spit bad information out. The fraction bar thing is alpha f1. Okay, lots of things we could do. We could look at the graph of it. Who knows what the sine of cosine and natural log, who knows what that looks like. That's kind of crazy looking. But that, I don't know, that's weird. That's what you get when you combine all that stuff. That's not really what I want, though. What I want is the derivative. So let's go to math. Actually, go back to the main screen. So let's get off of the graph screen. Go to the main screen, hit math, and one of the options down there is, I'll grab a calculator that won't do some things, but I don't need those things. Option number 8, in derivative, so press that, and then hopefully you recognize the notation that it brings up. So it means take the derivative of something with respect to something at something equals something. So I'm doing d dx, and I'm taking the derivative of, I put this in for y1, so I'm going to put y1 in that box. So vars, I need a variable, so vars, I need a y variable, y1 at x equals 2. Oh, I also need to make sure I'm in radians, because this has sines and cosines in it. Okay. Always, always, always 3 decimals when we do calculator things. 1.079. You want to be in radians. You'll always be in radians in here. It says indicate units of measure, but it doesn't give... It doesn't give me what... Oh, yeah, it is. Sorry, feet per minute. So what would acceleration be in? feet per minute squared. A few more questions. Particle moves along the x-axis so that its velocity is given by. So I'm going to just go back to y1, and I'm going to, actually it would be helpful sometimes to label, kind of remind yourself that that's what's in for y1. Especially later on if we get sort of two particles doing things, then you want to label who's what so you don't lose track of it. So y1 is natural log of the inverse tangent of e to the x. It's like, what kind of ridiculous equation is that? Okay, part A, find the acceleration. Okay, if I have velocity and I want acceleration, how do I find it? Take the derivative. So I want dv dt at time equals 2. Actually, you don't even have to change anything because that's the same. I mean, that's not the answer. That's the answer from the previous one. But if you go do it again, it's exactly the same command. It's just y1 has changed. Good. 0.093. And by the way, this is sufficient work. If it's a calculator problem, I know, the AP graders know that the calculator can do this. And so you don't have to show any more work than that. You got to tell them that acceleration is dv dt, but after that, they're not expecting you to, find this derivative by hand. Yep. That's the same. That would be the same thing as v prime at 2.
Okay.
Yep, that would be okay. Part B. Is the speed of the particle increasing or decreasing at time 2? Okay, how do we find out speed increasing or decreasing? Looking at the positives and negatives, if A and V have the same sign. So A of 2 we already know. That's 0.093. How do I find V of 2? Plug in 2 to y1. Your calculator understands function notation. So you can do the table if you want, you can do the graph if you want, but you can also just do y1 at 2. Again, your calculator understands function notation, so you can use that. And V of 2 is 0.362. So what does that mean? If A is 0.093 and V is 0.362, is the speed increasing or decreasing?
Increasing.
Why is it increasing? Because they have the same sign. Speed increasing, but you need to say that because A and V have the same sign at t equals 2. Ian?
Can you put in the V2 again?
It's just y1 at 2 because y1 is V.
I swear I didn't do that. No, I'm pretty sure I handed it to her and then she started like pressing on buttons.
Okay, everybody got 0.362 and understand why they're the same? All right, part C. At times greater than 0, find the time where the particle is farthest to the left. Farthest to the left. So moving left and then turning around. So what would be going on in terms of V at the spot where we turn around? Like, what's the sign of V if we're moving to the left? And then if we turn around and now we're moving to the right, positive. So it'll be a spot where V changes from negative to positive. Now I don't know which spot it'll be, so hopefully I can look at the graph and figure out what's going on here. Okay, so that's my graph of V. Window, I don't need to look at the negatives. I have no idea how far out I should go, so 10 seems reasonable, maybe, I don't know. Well, that's not much of a graph, is it? Let's change our window. Our Y scale could be a lot smaller. So maybe -1 to 1 for the Y scale. That way we'll zoom way in on it. It looks like X didn't need to go out that far either. Let's go X equals X to 5. Let's see if that helps. Okay. I wonder if I should go further in the X direction now that I said that. Okay. Looks like maybe there's an asymptote there. Let's see. So the stuff left of 0 doesn't matter because the thing starts at time greater than 0. So it changes from negative to positive only one time. So that would be the only spot where it changes from moving left, turns around and comes back to the right. So whatever that time value is my answer. I don't have to worry about. I was worried if there were multiple places where that happened, it'd be tricky to figure out. But since it only happened once, I need to find that spot. So I need to find that 0. So second Calc 0. Left of the 0, press enter. Right of the 0, press enter. Guess, enter. And so at t equals 0.443, pause there for a second. Like just saying it, because if it changes negative to positive at multiple places, then I'd have to know, like, well, which place is the farthest of the left turnarounds. So I think I'm just going to say it only. That's the only place it happens. That's the only turnaround at the left side that happens. So that's got to be the farthest left that it goes. Okay, let's sort of rewind, and I'm going to work this problem a slightly separate way, still on the calculator, that some people like. So get to the graph where you can see what's going on the graph. And let's just back up. If I want the acceleration, I know that's dv dt. And so some people are thinking it's the slope of the graph. So you can go second calc, and it will tell you, excuse me, it'll tell you dy dx. And you just have to put in, well, where do you want dy dx? And you can type in 2. Like, you can't scroll there exactly, so I'm just going to type in 2. So dy dx at 2 is 0.093. So if it helps to sort of visually see what's going on, maybe you'd rather do it on the graph. You can also maybe tell that slope is positive. You can definitely tell that the slope is positive just by looking at it. What else did we want? V of 2. So second calc, gentlemen, please. If you want the value of v at 2, you can do value and type in 2. And the y value there is 0.362. So you can do everything either on the graph screen or sort of back on the home screen. You can do it either way. You can find values, you can find slopes at either spot. So it's sort of whichever way you like to do it. Whichever way makes more sense. I think I usually do it on the graph because I like looking at the picture and trying to coordinate what the picture says with what the numbers say. And again, there's not a whole lot of work to show on those, but the concepts are still there. Like you have to know acceleration is dv dt. You have to know what speeding up and slowing down meant. You had to think about farthest left, what did that mean? Alright, so today's assignment is worksheet number 3. Tomorrow we won't have a new assignment, or Friday I guess. I'll just work some problems from worksheet number 3. So do some of them, so that you know what questions to ask, but we'll work some together on Friday. And then due Friday is worksheet 1 and 2. So you still got 30 minutes left. So if you haven't already done worksheet 2 or a big chunk of worksheet 2, you got 30 minutes in class right now to work on worksheet 2. If you have done worksheet 2, then you can start working on worksheet 3.